Hello all. In this video, we will understand how do we solve an ordinary differential equation with the help of variable separable method. Before starting with variable separable method, we must know what is the variable separable form. A differential equation is said to be in a variable separable form if it is of the form dy by dx is equals to function of y into function of x. For example, dy by dx is equals to e to the power x plus y. We can write it as e to the power y into e to the power x. Here e to the power y is my function h of y and e to the power x is g of x. Now, if we have a differential equation of the form star, how do we solve this differential equation? Let us do some derivation here. This derivation part is optional for you. If you want to skip, you can directly move to the question solving part of this video. Now, let dy by dx is equals to h of y into g of x. I can also write this equation as 1 upon h of y dy by dx is equals to g of x. And if y is a solution of the differential equation star, then it will look like y is equals to f of x. So let y is equals to f of x be a solution of the given differential equation, which is star. Implies we can also derivate this y is equals to f of x with respect to x. So it becomes dy by dx is equals to f dash x. Let me mark this as equation number 1 and this as equation number 2. Using the value of dy by dx from equation number 2, equation number 1 becomes 1 upon h of y into f dash x is equals to g of x. This is also 1 upon h of the value of y was f of x into f dash x is equals to g of x. Now both the left hand side and the right hand side are in the variable x, so I can integrate equation number 3 with respect to x on both sides. We get integration f dash x upon h of f of x dx is equals to g of x dx plus c, and this equation can also be written as integration dy by h of y is equals to integration g of x into dx plus c. Now look, we have an equation in the form of star, and if I want to find a solution of this differential equation, I can directly use this as a result to find the solution of the given differential equation star. So I hope you have made an understanding that if we have a variable separable form, we will directly apply this form. Let us do some questions based on this form. Find the solution of the following differential equation. The first part says x into dy by dx is equals to 1 minus 2x square into 10y. To solve this variable separable form, we will collect the x terms on the right hand side and y terms on the left hand side. So the given differential equation becomes 1 upon 10y dy is equals to 1 minus 2x square upon x into dx. Simplifying them, this is cot y into dy is equals to 1 by x minus 2x into dx. Integrating both sides, we get integration of cot of y into dy is equals to integration of 1 by x minus 2x dx, and this becomes log of sin y is equals to log of x minus x square plus c. So this is my solution to the given differential equation. Second question. Dy by dx is equals to e to the power 2x minus 3y plus 4x square e to the power minus 3y. The given differential equation is dy by dx is equals to, can I take e to the power minus 3y common? So this becomes e to the power 2x plus 4x square. This is my variable separable form, so I can write it as e to the power 3y dy is equals to e to the power 2x plus 4x square into dx. Integrating both sides, we get integration e to the power 3y dy is equals to e to the power 2x plus 4x square into dx. This becomes e to the power 3y by 3 is equals to e to the power 2x by 2 plus 4x cubed by 3 plus c, which is the solution to my given differential equation. Third question, x into e to the power 4y minus 1 dy by dx plus x square minus 1 into e to the power 2y is equals to 0, where the value of x is greater than 0. Solution, we are given that x into e to the power 4y minus 1 dy by dx. Taking the other term on the right hand side, it becomes 1 minus x square e to the power 2y. Now, this is my variable separable form. So, collecting the y terms on the one side, it becomes e to the power 4y minus 1 divided by e to the power 2y. dy is equals to 1 minus x square divided by x dx. This becomes e to the power 2y minus e to the power minus 2y dy is equals to 1 by x minus x dx. Integrating both sides, we get integration of e to the power 2y minus e to the power minus 2y dy is equals to integration of 1 by x minus x dx, implies e to the power 2y by 2 minus e to the power minus 2y by minus 2 is equals to log of x minus x square by 2 plus c. Taking 2 common, this becomes e to the power 2y plus e to the power minus 2y is equals to 2 times log x minus x square plus c, or 2c. Next question, y minus x into dy by dx is equals to a into y square plus dy by dx The given differential equation is y minus x into dy by dx is equals to a times y square plus a times dy by dx. Taking the derivative term one side, it becomes x plus a dy by dx is equals to a y square minus y. Applying the variable separable form, this becomes minus of dy divided by a y square minus y is equals to dx upon x plus a. The left hand side becomes y times ay minus 1 is equals to dx upon x plus a. Using partial fractions, left hand side becomes minus of a upon ay minus 1 minus 1 upon y. dy is equals to dx upon x plus a. Integrating both sides, it becomes integration of 1 by y minus a upon ay minus 1 dy is equals to dx upon x plus a. This becomes log of y minus log of ay minus 1 is equals to log of x plus a plus log of c. This becomes log of y upon ay minus 1 is equals to log of c times x plus a. Taking antilog both sides, this becomes y upon ay minus 1 is equals to c times x plus a. So this is the solution to my given differential equation. I hope you have made an understanding how to solve a differential equation which is in variable separable form. Keep learning.